Okay, so then this is my next video where we're continuing to do the derivatives of trig functions, but we just did sine and cosine, so let's do y equals secant x, and then we'll do y equals cosecant x, and it's going to be essentially the same thing. So this, you should know y equals secant x. I could rewrite that as 1 over cosine x. And I can rewrite that as cosine x to negative 1. Well, now, that's a chain rule problem. And I've been doing chain rule, and this is why we need chain rule, and boom, here it goes. So I can write y equals u to the negative 1. And I can say u equals cosine x, and so now I can say dy du is equal to negative u to the negative 2, du dx is equal to negative sine x, and so then I've got dy dx is equal to du dx times dy du, and so I get negative sine x times negative u to the negative 2, and I'm going to rewrite that as the negatives are going to cancel. That u is cosine x, so I'm going to get sine x over cosine squared of x, but I'm not done yet. I'm going to write that as 1 over cosine x times sine x over cosine x. And finally, I'm going to write that as secant x times tangent x. Okay? So there's how you would go around about that. And so now I'm just going to give you some basic just memorization ones. So y equals secant x, y prime is equal to secant x tangent x, y equals cosecant x, y prime is equal to negative cosecant x cotangent x. I'll let you prove that one on your own. Y equals tangent x, y prime equals secant squared x. That's a really important one using quotient rule. Quotient rule or product rule, but we haven't done quotient rule or product rule yet, so we'll come back to do that one at some point in time. Okay, so going back to here, anytime you take the derivative of something that starts with co, it brings a negative out front. So if I've already got a negative out front and I take the derivative of something that's got a co, it goes back to being positive. Every single time I take the derivative of something that's got a co out front, it brings a negative out front. So co, negative, when I take the derivative. All right. Now, so then, once again, we've got our chain rule, so then now we can do a little chain rule problem. Y equals tangent of e to the square root of x. Okay, looks pretty daunting, but it's actually, we're going to just break it down. We're going to say y equals tangent of u equals e to the v, and v equals x to the 1/2. because I really don't like that radical sign. I prefer to write it in exponential notation. So dy du is equal to secant squared u. Du dv is equal to the derivative of e to the v is e to the v. Derivative dv dx is 1/2 x to the negative 1/2. So then dy dx is going to equal to dv dx times du dv times dv dy du. And so dy dx is going to equal to 1/2 x to the negative 1/2 e to the x to the 1/2 tangent of e to the x to the 1/2. And so there is a function inside of a function inside of a function. So that is that's a double chain rule. With exponents and trig. And if you just know each individual rule as you go along, the whole point of calculus is we have very simple rules, but then we start to string them together into longer and longer and longer chains. Okay, that's it for this video.